through the examples 5, 11, and 13 from homework number 7. In the first video for homework number 7, we looked at finding the area between two curves, or in other words, a shaded region, when the graph was given to you, like examples 1 and 3, or from the book, examples 1, 2, 3, and 4. And in these examples, we're already given a graph. Let's recap the process we used. First, you find a intersection point using previous algebra, so you could solve that system using graphing, substitution, or the elimination method. You might know the elimination method as a subtraction method. And then next, you set up the integrals as a difference. Remember that depending on if you're working with a function over x or a function over y, we either use the top minus the bottom function or the rightmost function minus the left function. The way you could sum this up for either case, rather than trying to memorize a process, the way that you could process this in your mind is that it's always the greater side of a number line minus the smaller or lesser side of the number line. So if we've got the function on the top, that's where the y is greatest minus the smaller y. Or right to left, this is where the x is greatest and the x is smallest. So top minus the bottom, or the right minus left. Let's look at homework problem number 8 in the textbook. And that's going to be similar to the assigned problem number 5. But here's how we could work. The only difference is that now we've got to do our own graphing. We're going to graph the parabola x squared minus 2x, that's the red function. And then graph the line y equals x plus 4, that's the blue function. Find the two intersection points. I did that with substitution. Since we have two y's, we could let x plus 4 substitute in for this y. So we get x plus 4 equals x squared minus 2x. Solve that quadratic equation by setting it to 0, factoring, and then set each factor x minus 4 equal to 0 and x plus 1 equal to 0. So when we solve that, we get x equals 4, x equals negative 1. Once we have the two x's, we can find the y value by finding f of 4 equals 8 and f of negative 1 equals 3. So we get the two ordered pair points, the two intersection points, as 4, 8 and negative 1, 3. The next step is to set this an integral with the top function. The blue line is clearly above the red parabola. So we've got our x plus 4 minus x squared minus 2x. So we're going to integrate from x equals, if you look at those inner points again, we had x equal to negative 1 up to x equals positive 4. So we're going to integrate from negative 1 to 4. We're going to do the integration from x equals negative 1 to x equals 4 of x plus 4 minus x squared minus negative 2, that's plus 2x. When we simplify that, we get negative x squared, or I really should say the opposite of x squared, plus 3x plus 4, integrated over dx. When you do the integration, you get negative 1/3 x cubed plus 3 x squared plus 4x. Substitute in a 4 for x to get this pink expression. Substitute a negative 1 in for x to get this purple expression. So for the pink, substituting in a 4, we have negative 64 over 3 plus 64 plus 16. And then we subtract the purple, 1/3 plus 3/2 minus 4, for a total difference of 125 over 6. That's the example number 8 from the textbook. And the next assigned problem is number 11. And you do this the same way that we do the last example. start with a graph, and then find the intersection points. And then we set this up as a difference, which is going to be the rightmost function minus the leftmost. So when you try problem number 11 from the textbook, you can check your answer in the back of the book, but you're going to follow the same example that was just worked out, book example number 8, except that we're going to subtract the rightmost function from minus the leftmost function. And let's look at the next example. And even though you do this next example in the same way, I want to show this one to you because we get a really neat shortcut here with this. So you should be doing problem number 13 out of the book, but this is similar to number 15 and that we get this cool symmetry shortcut. And to help us with this, that wasn't intended to be there, so sorry. The official Lego guy making a guest appearance is our stormtrooper. Thank you to my son Zachary for letting us borrow this stormtrooper. But the stormtrooper is gone. The stormtrooper is going to use a cool symmetry shortcut for this problem. This guy just doesn't want it there. And the reason this shortcut is going to work out is because the graph of the uppermost function and the lower function, we get two sides of the axis that are symmetrical. Really, we're looking for the area of this whole piece here. But they're going to be identical on both sides. So we can actually just integrate to find the green side only. So we're going to integrate from x equals 0, x equals pi over 3. Double that area to get the total area. Let me walk you through the example. This is book example number 15. We're given y equals secant squared x and y equals 8 cosine x. We're finding the curves, and it's given that we're doing from the opposite of pi over 3 up to pi over 3. Because we had to have that restraint because it keeps going. Remember, with the cosine or secant, the functions keep going, so we get an infinite number of intersections. But we're only looking for this particular area, the area that goes from negative pi over 3 up to pi over 3. When we set these two functions equal to each other so that we can find the intersections, you've got to do a little bit of pre-calculus. And the way I'm doing this is I'm going to write secant squared as 1 over cosine squared, because secant is equal to 1 over cosine. So I can say secant squared is 1 over cosine squared. And if I have 1 over cosine squared equals 8 cosine x over 1, I can cross multiply to get 1 times 1 equals cosine squared times 8 cosine x equals 8 cosine cubed. So we get 1 time equals 8 cosine cubed x. Cosine squared times 8 cosine is 8 cosine cubed. So we can solve this for cosine cubed by 8 and get cosine cubed equals 1 over 8. So the cube root of both sides would give us that cosine is equal to 1/2. This is all just a review of pre-calculus. And if you're struggling with this part, don't panic much, because the examples I'm going to ask you to do for homework are not going to include this trigonometry examples. But we would then use the unit circle to say that if cosine is 1/2, that happens when theta is pi over 3, or in this case x. X is pi over 3, or x is the opposite of pi over 3. So that's how we get our two intersection points. Now we're going to integrate from negative pi over 3 to pi over 3, the uppermost, that's the blue 8 cosine x, minus the lower function, secant squared x, and we're going to integrate over dx. Here's the cool shortcut. Rather than integrating from negative pi 3 to pi over 3, we could integrate from 0 to pi over 3 and double the result, because going from x equals 0 to pi over 3 gives us this green region. And then we just double this green region because the green and orange are identical. So we could use this little shortcut because symmetry. So we'd get 2 times this. When we integrate this, we get 8 sine x minus tangent x from 0 to pi over 3. Substituting in a pi over 3 and then substituting in a 0 and subtracting those, you should get 3 square root of 3. And then when you double it, you get 6 square root of 3 as the end result. So thank you to this stormtrooper for helping us with this problem. And if you can remember that it was the stormtrooper in the video, that might give you a bonus point later on in the course. That point 1, I hope that those videos will help you do those examples.